everybody, welcome to part 1 of 3 videos tonight. It's a long one. We're going to be reviewing about factoring polynomials. So the first way, and the one that's used the most, is the GCF, or the greatest common factor. So you look at the two terms, or however many terms you have, and you're going to figure out what value goes into both of them. So let's look at the coefficients first, 24 and 54. Which value can go into both of these, and it's the biggest of all of them? So like, think of your factors of 24, think of your factors of 54. The greatest common factor in this case is going to be a 6. Then look at your variables. How many y's could I pull out of both of these? Well, this one has 4 and this one has 3, so I can pull out at least 3 of them. Then it's our job to figure out what is left behind. If I pull a 6 out of 24, I have a factor of 4 left over. If I pull 3 y's out of 4 y's, I get 1 y left over. Finally, if I'm taking a 6 out of negative 54, what's remaining is a negative 9. If I take 3 y's out of 3 y's, there's no y's left. All right, and that's that. Talk about this next one. Thinking about the factors of 51 and 17, those are some ugly numbers. Well, the factors of 17 are only 1 and 17. So let's see if 17 fits into 51. So 17 times 2 is 34. Maybe 17 times 3? 3 times 7 is 21. 3 times 1 is 3, plus 2 is 51. So this does work. Oops, before I do that, keep your 17. How many A's could I pull out of both? I can pull out 3 A's. This one has 8 and that one has 3, so I can pull out at least 3. B to the 4th power, B to the 5th power, I can pull out at least 4 B's. What's left over? If I take a 17 out of 51, there's a factor of 3 remaining. If I take 3 A's out of 8 to the 8th power, I've got 5 A's remaining. If I take 4 B's away out of 4 B's, that's it. If I take a 17 out of 17, that's going to be a 1. And I could put the 1 here, but I don't think I'm going to. If I take 3 A's out of A3, that's going to be nothing. If I take B4 out of B5, I'm left with 1B. I could put the 1 there, but you don't need to. All right, greatest common factor, done. Difference of squares. So the rule for factoring with the difference of squares is if you have something like a perfect square subtract, that's what difference means, subtraction, another perfect square, then that can be rewritten as x plus y and x minus y. Before we get started, let's talk about perfect squares. So inputs of perfect squares, you should know up till the 10th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we square all of those, 1 squared is 1, 2 squared is 4, and you keep going. So you should have definitely up to 10 in your muscle memory in your brain. I think it's a good idea to go up to 12, but at least 10, that is the minimum. All right, so we want to figure out if both of these are a perfect square and there's going to be a difference in between them. So if there's difference, it's subtraction. What times itself gives me 36w squared? Well, what gives me 36 squared? 6. And then a w. 6w squared gives me 36w squared. What squared gives me 25? 5. Well, there's my x and my y that I'm going to put into this rule. So if I've got a perfect square subtracting another perfect square, I can rewrite that as 6w plus 5 and 6w minus 5. Simple as that. Let's do the next one. What times itself gives me 1 over 44? Well, 144 is a perfect square. Like I mentioned earlier, you should probably go up to 12. This is 112 squared. And then what times itself would give me all of this? Well, remember power to power rule is that this too is multiplied into everything. So I can say r cubed, because r cubed squared gives me r to the 6. I can say s squared, because s squared to the power of 2 gives me s to the 4th. Now that I have my x and my y, I'm going to put it in my rule. Something being added, something being subtracted. We're going to have 1/12 plus r cubed s squared and 1/12 minus r cubed s squared. There's that. Let's do number 6. I'm going to skip number 5 for the time being. What times itself gives me this first value? Well, 9's a perfect square. It's going to be 3. What times itself gives me a to the 4th? That's a squared. And what times itself gives me b squared? Just b. Then this one, what times itself gives me 100? That's 10. And then c times itself will give me c squared. So let's put it in our rule. We're going to add something and minus something. 3a squared b plus 10c and 3a squared b minus 10c is my answer. I skipped this one. First of all, we could do what we've been doing and say that this is going to be 4x squared and this one's going to be 1 squared. But we don't want to do that because it's not the difference of squares. This is addition. Even if I set this one up, like if I didn't catch that plus sign right here, and I try to say 4x squared plus 1 times 4x squared minus 1, the big problem here is that when we multiply these together, look, 1 times negative 1 is going to give me a negative 1, not a plus 1. So this does not work. This is actually a prime factor. Kind of like how 17 is a prime number. You can only multiply 17 times 1. This one cannot be factored. It can only be multiplied by 1, and it cannot be simplified further. That's the end of the first video. See you on the next two.